Hey everyone, and welcome back to another deep dive.
Yeah,
You ready to tackle something
always.
pretty dense? Black holes.
Oh, yeah.
But don't worry, we're going to break it down and hopefully make it fun too.
Absolutely.
Today, we're diving into some research
Yeah.
that's really turning some heads.
Mm-hmm.
It's challenging
Yeah.
what we thought we knew about black holes.
Totally.
This comes from the University of Barcelona,
Mm-hmm.
and they're saying something pretty wild.
Yeah.
They're saying black holes might not have singularities after all.
Right.
This is based on an article from scitechdaily.com called No More Singularities.
Mm-hmm.
Quantum gravity could finally solve the black hole mystery.
Big implications.
So get ready for a mind-bending journey as we unpack
Yeah, absolutely.
this cutting-edge science. Now, maybe we should take a step back.
Yeah.
What even is a singularity?
Right. So a singularity in the context of a black hole is this point of infinite density where all the matter gets squeezed into an infinitely small point. It's like imagine trying to cram the entire Earth into something smaller than a pinhead.
Right. It's where the laws of physics as we know them just kind of break down.
Completely. They just don't apply.
Yeah, it's always been this kind of like head-scratcher for physicists. Einstein's theory of general relativity predicts these singularities,
Yeah.
but it doesn't really say how they can exist.
Right. It kind of just leaves you hanging with this infinity.
Yeah, exactly.
Yeah, right.
So how have scientists tried to address this so-called singularity problem?
So some theories have relied on this concept of exotic matter.
Okay.
And this would be matter with really unusual properties, like negative energy density.
Negative energy density.
It's pretty wild and theoretical.
I mean, has anyone ever actually seen this exotic matter?
No, not at all.
Okay.
It's a completely hypothetical.
So not a very satisfying solution.
Not really, no.
But this new research is suggesting that we
Yeah.
don't need exotic matter at all.
Exactly. This is the really cool part. They're saying black holes can form from pure gravity.
Pure gravity.
Yeah. So they've looked at these equations and they've incorporated elements of quantum gravity.
Okay.
That's the theory that tries to unify Einstein's theory of gravity with quantum mechanics.
So they're kind of like adding an extra layer
Exactly.
to our understanding of gravity?
Yeah. They're saying that in these extreme environments of a black hole, we need a more complete picture of gravity.
I see.
And by doing that, they've actually shown
Yeah.
that you don't need these singularities to form a black hole.
So you're saying by tweaking these equations,
Mm-hmm.
suddenly singularities aren't necessary anymore.
That's right.
So then instead of collapsing into this point of infinite density,
Yeah.
what happens to the matter inside these singularity-free black holes?
So they call these regular black holes.
Okay.
And they still have an event horizon, so that point of no return.
Uh-huh.
But instead of a singularity at the center, they propose that the matter reaches a finite density.
Still extremely dense, but not infinitely dense.
Exactly.
So in other words, these regular black holes,
Yeah.
they're still extreme, but they don't actually break the laws of physics.
Yeah, they play by the rules.
This seems like kind of a big deal.
It's huge.
Doesn't it?
Yeah, it really is.
It makes the picture of the universe seem a lot more,
Yeah. Elegant and consistent.
yeah, elegant is a good word.
Right.
And it really makes you wonder what else we might discover as we keep exploring these mysteries.
Yeah, absolutely. It opens up a whole new set of questions. It really changes how we think about black holes and how they fit into the universe.
Yeah, so it's not just about what's going on inside the black hole itself.
Right. It's about the bigger picture, like how these objects change over time and eventually die.
And what about our understanding of gravity and space-time?
Oh, yeah, that too. It even has implications for the fate of the entire universe.
Wow, this is getting pretty deep.
It is.
So in this model where there's no singularity,
Yeah.
what's actually at the center of a black hole?
Well, picture this, a tiny, incredibly dense sphere, but not infinitely dense.
Okay.
It's the result of matter collapsing under its own gravity. But because of these quantum gravity corrections, it stops collapsing at a certain point.
So it's almost like there's this quantum pressure pushing back against the gravity.
You could think of it that way.
And does this new model help solve some of those issues that we talked about before?
You mean with the laws of thermodynamics?
Exactly. Yeah, those laws say that energy can't be destroyed.
Right, and that was a big problem with the singularity idea.
So you're saying that these regular black holes,
Yeah.
they actually follow the laws of thermodynamics.
Exactly. Information can actually be preserved even inside a black hole.
This new model seems to be a lot more consistent with what we know about the universe.
Yeah, it ties things together in a really elegant way.
It's amazing how this research is kind of shifting our perspective on black holes.
It's a paradigm shift for sure.
What kind of impact do you think this will have on future research in this area?
Oh, it's exciting. This is just the tip of the iceberg. There's so much more to explore.
Like what specifically?
Well, for one thing, they need to see if this model holds true in our own four-dimensional universe.
Right, because so far they've been working in higher dimensions.
Yeah, and the math gets a lot more complex when you try to apply it to our universe.
Yeah, I can imagine.
But if they can make it work,
Mhm.
it could lead to some amazing new discoveries.
Like what kind of discoveries?
Well, think about it. If regular black holes really exist,
Yeah.
they might leave behind some unique signals that we could actually detect with our telescopes.
So we could actually observe the effects of quantum gravity in action.
Exactly. And that could help us unlock some of the biggest mysteries in the universe, like dark matter and dark energy.
This is incredible. It's like we're on the verge of a whole new era of black hole research.
I think you're right. And who knows what other amazing things we'll find along the way.
Wow, it feels like we've gone on this incredible journey
Yeah.
through the heart of a black hole and come out the other side with a whole new way of looking at things.
Yeah, we started with these crazy singularities where everything breaks down, and now we have this much more elegant picture.
We've learned that those singularities might not actually exist,
Right.
and that black holes could be these regular objects that actually follow the laws of physics.
It's a big shift in our thinking.
And this research from the University of Barcelona,
Yeah.
it's showing us that we might not need things like exotic matter to explain how black holes work.
Right. Just good old gravity and a little bit of quantum mechanics.
It's amazing how this research is not just changing how we think about black holes,
Yeah.
but it's also pushing us closer to this unified theory of physics.
Absolutely. It's connecting the really big stuff like the cosmos with the really small stuff like quantum mechanics.
So what's next for this research?
Well, one of the big things they want to do is see how this model works in our own universe.
Right, because so far they've been working in higher dimensions.
Exactly, and that's a whole other challenge.
Yeah, but if they can make it work, it could lead to some really amazing observations.
Think about it. If regular black holes are out there,
Yeah.
they might leave behind some telltale signs.
And we might be able to see those signs with our telescopes.
Exactly. We could actually observe the effects of quantum gravity at work.
Wow, that would be incredible.
It would open up a whole new window into the universe.
Well, deep divers, it seems like we've reached the end of our journey for today.
Yeah, but the exploration doesn't have to stop here.
We'd love to hear your thoughts on all of this.
Yeah, leave us a comment and let us know what you think.
Does this research change how you see black holes?
And what other mysteries of the universe would you like us to deep dive into?
We're always looking for new topics to explore.
Absolutely. So keep those suggestions coming.
And if you enjoyed this deep dive,
Yeah.
be sure to like and subscribe and hit that notification bell.
That way you won't miss any of our future episodes.
We've got some amazing topics coming up that we can't wait to share with you.
So until next time, keep those brains buzzing.
Yeah. And keep exploring the universe.
There's always something new to discover out there.